This module introduced you to the concept of pattern matching. This is a great addition to C#, and it changes the way that you express yourself. Simply explained, pattern matching is a way to construct an expression that lets you determine what an object is and what it isn't. It allows you to check, for example, how the object can be deconstructed, what properties has certain values, which subclass is used in runtime, and a whole lot more. Being able to express the intent with less ambiguity can be the difference between a great method and a buggy one. Pattern matching helps with this by introducing different ways to inspect the object and different ways to write patterns. Throughout this module, we explored the different patterns available in C#. I can almost guarantee that newer versions of C# will get even more patterns added for more common situations. We learned about the following patterns. The type pattern lets you write a pattern that checks which runtime type the object is. The declaration pattern lets you map the matched object into a local variable of that type. The constant pattern lets you write a pattern that compares a property or position or tuple value using a constant value. This could be a constant defined in your class, a number, a character, or a string literal. The relational pattern lets you use the comparison operators to check if the value matches your constant. The logical patterns let you introduce negated not, disjunctive or, as well as conjunctive and patterns. These three different logical patterns can be used together to produce complex, yet readable patterns. You could check that a property falls within a certain range, and that the type does not match two different subclasses. Another very good use case of the negated not pattern is to check if an instance is not null. The property pattern lets you check if the property has a certain value by allowing you to write a pattern for that property. This is a nested pattern that will first check if you have an instance and then evaluate the pattern for the property. You could use this in combination with the relational pattern or with other patterns as well. The positional pattern lets you write a pattern that matches on the values that are produced when deconstructing a type. It also lets you write a pattern that matches the value inside a tuple. The var pattern lets you capture the object into a local variable. It will be captured even if it's null. This is just the same as a default case, but where you'd want to use the value. The discard pattern lets you define a default case, or simply state that you do not care about capturing the value into a local variable, and that it can be of any value. Add this to the end of your switch expression, and you'll ensure that you handle all cases. Finally, the parenthesized pattern allows you to group different patterns. You could define that a type is not one or the other. The patterns can be used in combination with case guards. In cases where you'd want to check, for example, the type, and then validate that a method returned a certain value. You could then do this using a case guard. Pattern matching is truly powerful. There's a reason this has existed in many programming languages for a long time. It makes it easier to express yourself, and ultimately, it can make your code more understandable. However, as with any language feature, you should use it with caution. And always consider if others understand the code just as well as you do. Going forward, do we have to add the deconstruct method to all our objects ourselves? And what about value-based equality? This is something that we often have to add ourselves. If every developer has to do this, that seems a little bit unnecessary. Isn't there a way to automatically get all the functionality in a class that we normally must add ourselves? Next, we'll convert the order class into a record type. This will introduce a whole lot of functionality behind the scenes, while reducing the amount of code and headache.